Hi guys, Ms. Griffin. We're looking at Unit 8, Skill 9A. We actually have an A, B, and a C to this, so we need to watch A, B, and C due today, our next class. So make sure that you watch all three parts. Our essential question says, how can we model a situation that happens every n times? So we have this brand new equation. Take a second to write that essential question down if you need to. We have this new equation that is similar to what you've seen, but we have to adjust based on the fact that this is going to happen every certain number of times. N is just a number, right? So say that I get a population that doubles every 5 minutes. That would be crazy, but N would be 5 because it's happening every 5 minutes, right? So in this first example, we're actually talking about a population that is doubling, and this is talking about rabbits. So we've got this population of rabbits that doubles every 60 days. So doubling means that we are changing by 100%. Rate equals 100%. So in other words, R equals 1.0. And because it's happening every 60 days, this is how often it happens. So T equals 60. Excuse me, not T. N equals 60 because that's how often it happens. The initial population is 10, so our principal here is 10. Initial population is 10. They actually wrote the formula for us. Population equals 10 times 2 raised to the t over 60. So you see that time divided by the number of times that it happens, or how often it happens. So P is the population on day T. What is the value of T when the population is 320? So really, we're just plugging in here to solve. 320 equals 10 times 2 raised to the t over 60. And our goal is to get this term by itself because it's got the t in it that we're solving for, so divide out that 10. We've got 32 equals 2 raised to the t over 60. Now we're just going to apply those log rules that we've been using for a while now, and we're going to say that this is going to be log. This is my base of 2, so base stays base, and switch the other 2. So of 32 equals t over 60. And if you're thinking about the loop method, you would just loop in this direction because the equal sign is to the left. So now I type in log base 2 of 32, and we end up getting 5 equal to t over 60. And of course, to solve for t, we just have to undo this division, so multiply by 60 on both sides. So then t equals 300. It will take 300 days for the population to reach 320 rabbits. Flip it over so we can see another example. So in this example, we've got a rabbit population doubling every 4 weeks. Okay, so we got to think about that. We're going to be dividing by a value of 4. It's doubling, so the R, the rate, is 1.0 again. We're adding on a full amount of that population. And there are currently 5 rabbits, so our principal is 5. Or our initial value, in other words. So here it says if t represents the time in weeks, that's a good thing because then that matches, right? Write the equation. This should say P of t, population as a function of time, that would model the population of rabbits at any given time. So we have P of t equals the initial value 5 times 1 plus our rate, 1.0, raised to the power of time, but divided by 4 because it's happening every 4 weeks. So I'm just going to reduce or simplify this. P of t equals 5 times 2 raised to the t over 4. All we had to do was write the equation, so that's all that we're doing right there. If you want to see this in terms of like a table, what this would look like, we would have 0 weeks, 4 weeks, 8 weeks. At 0 weeks, we started at 5, then it doubles to make 10, then that doubles to make 20, so on and so forth. So if we wanted to, we could test out our equation, make sure that works. In the next part, part B, it says if T represents the time in days, right? The equation that would model the population of rabbits at any given time. So remember that we are doing this doubling thing every 4 weeks. And there are 7 days in a week, so we have to multiply to figure out how many days this doubling happens. 28 days. This is going to be our new n. So, right, this happens, population doubles every 28 days. Because 28 days is 4 weeks. Remember, again, it was just doubling every 4 weeks, but we needed it in terms of days. So we had to do a little conversion. So now I'm going to say population as a function of time is equal to our initial value still of 5. Our rate is still going to be 2, right? It's still doubling. And then this is just raised to the power of t over 28 because it's happening every 28 days. And again, if you want to see this in terms of a table, you would have 0 days, 28 days, then 56 days. Every 28 days, it's doubling starting at 5. So double goes to 10, double it goes to 20. So same exact table we had above, but this is in days. All right, so that was part A. We're going to flip over and watch part B now. Okay, so we're looking at skill 9B. How can we adjust an equation to meet requirements? That's pretty vague, but we're going to adjust an equation that we have written to meet certain requirements. Like maybe it started out as a yearly rate and we need to adjust it to be a monthly rate or a quarterly rate or whatever it happens to be. So this is our general formula here. It looks very, very similar to what you've seen, except there's a couple of extra things on it, right? So to having this p here, right, principal value, you're used to having the 1 plus r and raised to the nt, right? So that's if it's like compounding a certain number of times per period. But now we've got to adjust based on whether we're adjusting from a yearly rate to a quarterly rate or a yearly rate to a monthly rate or whatever it happens to be. So we're going to have to adjust the unit of time for the rate. So example 1 says if a credit card company charges 13.5 yearly interest. So here's our rate. And if we change that into a decimal, it will be 0.135, and this is per year. Keep that in mind. It says yearly interest. Which of the following calculations would be used in the process of calculating the monthly interest rate? So remember that months happen 12 times per year. I know it says which of the following, but we're just going to do it because there's no choices here. Right, so we're going to write out our yearly equation first. Just like normal. We've got our principal, which we don't know, so A equals some principal times 1 plus 0.135 raised to some time t. And now we're going to just combine like terms. 1.135 raised to the power t. Now we're going to talk about our monthly rate though. So to go from yearly to monthly, we have to adjust for those 12 months that happen in a year. So I'm going to write this same basic equation, but we have to adjust in 2 different ways. P times 1.135, except this 1.135 is going to be raised to the 12t now. And because I'm putting 12 on the outside, 12 times a year, right, 12 months in a year, I have to adjust for the 12 on the inside by raising it to the 1/12th power. Because what's happening, if you think about that, 1/12 times 12, power rule tells you to multiply. That would just cancel out to be a power of 1, right? So this keeps the equation balanced, but we're adjusting the rate because we are now calculating it with monthly interest instead of yearly interest. So now what we do is just type this part into the calculator to get a new rate. So type in calc to get the monthly rate. Everything else stays the same for now. So we have A equals P times, when I type that in, I get 1.01061, and it's still raised to the 12t because, again, it's happening at a monthly rate. And then it wants to know what the monthly rate's interest is, or the monthly interest rate actually is. So I have to take this piece here and think about the fact that it's 1 plus something. So this section here, this part after the decimal, the 0.01061, change it back into a percent by moving it over to the right too. So this is going to be a monthly rate of 1.061%. So again, let me just break down what we had to do back up above. We wrote down the initial equation based on the yearly interest rate, right? So we used this yearly interest rate, wrote down the equation, simplified it. But then because we're compounding or calculating this for a monthly interest rate, we had to adjust the time in years for months. So because we have 12 months in a year, put the 12 out here. Except that we have to keep this equation balanced, so we need to raise the inside to a power of 1/12. We're going to type this into the calculator to get our monthly rate, and then we can actually use the simplified version of that to calculate the monthly rate as a percent. Flip it over and we'll see another example. So with this one, it says we've got the study of an annual population of the red-winged blackbird in Fort Mill, South Carolina, shown by this population equation, B of t equals 750 times 1.16 raised to the power t, where t represents the number of years, so that's important to keep in mind. In terms of the monthly rate, okay, so here we go again with monthly. 12 months per year. Which of the following can be approximated for this population? So we still have to keep that 750, right, the initial population. Last time it was just represented by a P because we didn't know what that principal or the initial population was, or the initial, credit card payment. So we've got 1.16 raised to the t, but remember, again, we're adjusting for months, so it's 12t. And to adjust for that, to keep the equation balanced, we have to raise it to the power of 1/12. And again, the reason for that is because these 1/12 times 12 equals out to 1. So it keeps the equation balanced. But what I'm going to do next to simplify this equation, because you can clearly see that this is not an answer, we have to type this into the calc. So we still have the 750. Type that middle section into the calculator, still raised to the 12t. And that middle section ends up giving us 1.012. So the initial population stays the same. The only thing that changes is this 1 plus the rate, because the rate's changing to monthly. And so we can also check the correctness by typing it into our calculator, testing out this test 1.012 raised to the 12th power in your calculator, and you should equal out to 1.16, which was the original. So that tells you that you did it correctly. And again, our choice here should be choice 2. Okay, so now this is video A and B. Now go watch 8.9C from Rogers. Okay, so now you've got to watch the third part because A, B, and C are due next class. All right, let us know if you have questions. Make sure you start memorizing these formulas. Have a good one.